All right, welcome everybody to the main act of this conference. I hope the previous talks, you've enjoyed them. This is the very first time I'm going to deliver this talk. Again, like last year or 2 years ago, I don't remember. It was also the first time I delivered a talk at Vox Zurich. I'm really excited about this one because I'm trying something new. I can do this only once because this is a mutable thing that I'm doing now. I tried to sneak in a different talk by the program committee that they would have never accepted. Welcome to why your next application should be written with XSLT. How's that, Mario? XSLT is functional, wonderful. No, I'm just joking. Let me quickly open the real talk. Let me close this. So the actual talk is, oh my god. Oh crap, no, not today. Oh shit, did you see that? No, this is the worst nightmare ever for a speaker. Oh my god, Lukas, what do you do? A joke, quick joke. A SQL table walks into a bar and sees another table and says, "May I join you?" Yeah, right. I hope this works. Okay, let's see, talks. How many dBA to switch a light bulb? One too many. Oh my god, what's going on here? All right. Oh, this is getting worse and worse. You can still see the projection. Oh no. Okay, I'm still joking. You know, the real talk, of course, is not about XSLT. I designed these jokes. It's really, really bad. I should stop doing these jokes. Which talk do we have here today? Gerald, you can help me. Which one is it? The API talk? Not the ant. Okay, let's do that one. Thank you very much, Gerald. All right, so the talk you all came here for is 10 reasons why we love some APIs and why we hate some others. I really try to be funny. I don't know, it's kind of relaxing. You're already hungry for lunch and everything, so I try to relax people. And I do rehearse my talks with my wife. And my wife, you know, here's some live footage of my wife when I'm doing these jokes with her. Yeah, all right. But I'm going to talk to you about APIs today, and I want to talk about the emotional side of APIs, the thing that hardly anyone ever does. So this is me working with the file API that we've loved in the JDK forever. So I can just type file, period, and this is the local directory, and now I can assign it to var, which is even better, and then I can iterate the list of files inside that directory. That feels really great and useful, and I can use that for any directory. Now you see the mistake here. There's no TMP directory in Windows. It's called temp usually, so I get a null pointer exception. Yeah, right? I get a null pointer exception here. Nothing can be null. My dir is not null. I assigned it. I have a constructor call. It can't be null because list actually returns null arrays. Man, what kind of idea is that, right? So this is an API that triggers a null pointer exception when I for each loop over the array. This shouldn't happen, no? So we say, okay, that was the old days of JDK. In the old days, they made a lot of mistakes. Now we're doing better. We're doing much better now. So here's the stream API. We all love the stream API. We can stream a stream of 1 to 3 and skip the first element and then print it. And now here in JDK9, they've added new methods. There's now something like skip until. So I think I can use the predicate here. No, it's not until. I got it wrong. So it's not until. So logically, if it's not until, it must be while. I can skip while something is less than 2. Nope, no, that doesn't compile. It's drop while, right? I've learned skip in Java 8, now it's drop while. Why is this naming different, right? So this is, are you going to discover this method by your own or not? It's kind of the same thing. You're skipping a couple of elements and now you're dropping them. Now some of you know why this is the case. I'll get back to that example later. The bad thing here is there's inconsistent naming, right? So I don't feel good with that, personally. I don't like this kind of thing. What I like is this API. I really like this one. It's been a while since I've done some front-end development, so everything has changed again. But in the old days, when I still did it, 5 years ago, everything was this API, which you all know, jQuery. I can do this dollar notation, and then I have a set of DOM elements in my thing here, and I'm always operating on these sets of DOM elements. I can get the parents of all the sets, and I can get all the input elements that have a name attribute, or I can write it differently. It's all very intuitive, right? I've always found this extremely intuitive. I really liked jQuery when I still worked with it. This is me working with jQuery. It feels great. It feels great. Now, not everyone agrees, of course, but I thought it felt great. And why is that the case? We're going to discuss why these things are the case today. And it's not just about APIs. most of the stuff I'm talking about today could be said about languages too. Now, if you're on Twitter, all the time you see these people, oh, come on, just use Kotlin already, for fuck's sake. Just use Kotlin. Everyone says just use. It's the same thing with languages, right? You can have good APIs, bad APIs, and everyone tells you use this one. Just stop that Kotlin thing. I believe you now, but today is about APIs, something that people are much less emotional about often, I think, than languages. But I still think APIs are an important topic to discuss. I think APIs are a crucial part of the user experience. This is something that we don't often discuss in this way. Programs must be written for people to read and only incidentally for machines to execute. So this is a famous quote by Abel and Sussman from, I forgot if it's a paper or a book, but it's from Structure and Interpretation of Computer Programs. And this is about all of the programs. So this is about local variables, about iterations, like Mario told us before, we should use this or that style because it's more readable. But it's also about everything we expose to everyone else. It's also about APIs. Right? APIs is even more true here, must be written for people to read and write and use, and incidentally for machines to actually connect each other. So I found this quote here as well on Wikipedia. User experience refers to a person's emotions and attitudes about using a particular product, system, or service. And I think, let's introspect. We developers, we're persons as well, right? We're people. We're people. We have emotions. I think most of us maybe have not as much emotions as attitudes, but we do have those things. Don't let them tell you otherwise. We do have that stuff. In fact, I have an anecdote about developer attitudes here. So a Kotlin developer, an IntelliJ user, and a Mac user, they went to the bar. How do I know? After 1 minute, the whole bar knew. Yeah, okay. We have attitudes. Another quote here from NN Group. So if you ask anyone in the user experience field, NN Group is the company that comes to mind with all the expertise. User experience encompasses all aspects of the end user's interaction with the company, its services, and its products. And the end user, in the case of an API, is the programmer. I don't think this is really different. We've learned so much about how to deliver software to the end user, which is a non-programmer. But why do we make that distinction? If we are a company developing software for other software companies, then we will build an API. And the customer or the end user will be a programmer, so there's absolutely no difference. That company also defines usability, so that's not the same thing. You can look it up on their website. They have a nice description of all these terms. User experience is much more broad. Usability is one concept, and it's defined, they define it by 5 quality components. Learnability. So how long and how easy is it to learn something for the first time? How long does it take you? How efficient are you going to be when you use it 1,000 times after you've learned it? So that's a different thing. The learning curve and then the efficiency you get once you've learned it, that's a different thing in terms of usability. And then you go to a different project, you do this really cool SQL thing, and then you have to go back to this Java thing, which sucks, but can you remember how it worked? That's the third level. So even after 1 year, 2 years, if you've learned something, can you still profit from what you've learned? Errors is very important. Does the API, in this case, help you prevent errors? Because whatever the technique is, to help you prevent errors, or is it very subtle? Will you make very subtle errors that is very hard to discover? And when you have an error, can you recover from them? And ultimately, I like this bullet the most, the satisfaction. Because after all, we are humans. We are humans, and we want to have something pleasant to use, right? So this is how we work. We spend that much time with APIs. All the time we're spending coding is with APIs. And we want to have fun programming as well. An important observation in this list, I will show this list timing again. All of these things are not about technical details. Now, before this talk, we had a talk about technical details by Mario. It was very interesting. I think Mario has opinions about all of these subjects here, like null, the $1 billion mistake. There are a lot of prejudices against null. There are entire talks about null and how you should not use null, or maybe optional. And if you're using optional, never ever return null for an optional. I know a use case, but I'm not going to say it here. But null is not bad per se. The concept of null is not the bad thing. Null is bad when it's unexpected. And it is often unexpected, of course. But the concept is there's an absent value. We need that. somehow we need to encode this absent value. There's absolutely no way around that. Unless you're using a programming language like APL, which doesn't have a concept of a singular degree or arity. Everything is a collection there, so you have just 0. But usually you don't want to have distinction between lists and individual objects, and then you have to encode the absent value. So there's a lot of prejudices in tech, or false dichotomies, as we've heard before. There's also a lot of prejudices, funny that we have the same kind of examples, Mario, about databases. I've heard this so many times in my database career, right? This was from a previous MongoDB CEO. 2014, he claimed it was over. Now it's 2019, almost 5 years later. I'm not sure he was right, but it was bike shedding. It was prejudice. I also like Bruno Burgers from Microsoft. His tweets are really funny. There was a huge discussion here about YAML, which is horrible. YAML is so bad. Use XML, and I agree personally, but ultimately this is bike shedding. It gets you clicks, doesn't solve problems. All of these things have a history. Of course, don't get me wrong. This is just the wrong talk to talk about them. They have a history for many good reasons, but sometimes let's not fall for this cargo cult. Let's try to see the big picture. There's some exceptions. I like to troll my friend Nikolai. An exception. So I sometimes have these kind of things like I use Boolean types, the big letter Boolean type, true, false, and null in Java all the time. And Nikolai is always there to correct me. I love that. It keeps Nikolai busy, so that's when I do love bike shedding. So here's an example. I don't know if you know that you can actually break out of an if statement. You can break out of any statement in Java. This is excellent. I really love that. Also throw in an exception otherwise. So this is really procedural code, which I like, and Nikolai is always there to help me find my ways. So seriously, follow Nikolai for great Java content, and follow us both if you want to see these discussions on Twitter. But today, let's not bike shed. Let's forget the bike shed. Let's look at the 10 reasons why we love some APIs and why we hate some others. These are the ones I came up with, and before I started doing this talk, I just already listed down this list, and then I watched all the other people talk about this kind of topic, and incidentally, a lot of people have similar lists. This is nothing new. I'm not going to tell you anything new, but maybe something you don't think about every day. In my opinion, these are very important concepts in terms of API design: naming, simplicity, do one thing, types, discoverability, error handling, consistency, convenience, compatibility, and documentation. Or in short, colloquially called NSDAC. The D is silent. Okay, so you can remember this, NSDAC. Now, yesterday at the speaker's dinner, I had an excellent conversation with Gerald here, sitting here. Gerald, he said there's actually an 11th part because other humans made it, right? Courtesy, Gerald, follow him as well. Very funny guy. Okay, so naming. Mandatory joke here, right? I don't even have to Google it. Everyone tweets this joke. There are only 2 hard problems in computer science: cache invalidation, naming things, and off-by-1 errors. Huh, right? I like this one better. Yeah. Just like beating the dead horse. Naming is actually really simple. And by simple, I mean hard. Right? But it's simple. We'll soon see what simple means. All of us have felt like this before. Yes? Someone told us, don't use single letter variable names. The only exception is the for loop, where you have I, J, K, and I go to Z because I nest them. But otherwise, we don't have single letter variable names, and then we have to find these meaningful variable names. And if you think you have this problem, start again. When you're designing an API, it's much, much worse. Because then everyone has to read it, and then it has to really be a good name. Variables, okay, fine. We can still refactor and have endless discussions during coffee break, but in an API, this is really important. Now, here's a book I didn't read, but everyone refers it. When you talk about the ubiquitous language, that language that we design, and this book is about defining the language for the team, but you're also designing the language for the clients, for the stakeholders, for everyone ultimately, right? So this is just a quote from Wikipedia that talks to the team, but this language has to be really sound. When you have an API, because it's for humans and not machines, it has to be a really sound language that we define. Otherwise, it would be just generated characters if it was for the machine. I once did a joke on Twitter, and someone mentioned to me from, I think this is a British company, Woodstain, from Ronseal, and their slogan was, does exactly what it says on the tin. Right? So if any British here, I think you might recognize this. This is a really interesting concept and good marketing slogan. They're such a simple commodity vendor, right? Their products are simple. That simple. It removes wood stains, I would imagine, right? So it says that on the tin. It's a very simple name, and it does exactly that. Kind of like what we should do with APIs. Let's reiterate. The Stream API, I like this design, right? I had one project a long time ago with Infomix. Infomix, select, skip 10, limit 10. So this reminds me of the good old days. In the Stream API, skip and limit. So there must have been some Infomix person from IBM that helped design the Stream API. Otherwise, it's not possible to explain. The first time ever since skip and limit have been reiterated. But then they did the same concept and named it drop and take. Because someone else came probably, or someone else finally convinced the expert group. Scala and Haskell people call it drop and take. Because we have to be inviting those people to our communities, we have to use their language. Fine, there's no problem with that. But now we have those two names in parallel. And you know how this happens every single time. This is why it happens when someone else touches my API, right? So this is the reason why these things happen. Someone else does it. The language has changed. And in theory, this could be fixed, right? I either revert and call this limit while and skip while, or I refactor the old ones and call them drop and take. But we have backwards compatibility, right? So in a JDK, that's not an option. The JDK has almost nothing that's deprecated. With deprecation and then removal in maybe 10 major releases would be possible, but it's ugly. And they're not doing it this way. So we're getting here to see there's a trade-off between backwards compatibility and good, consistent names. And I like this tweet by Roman Elizarov from JetBrains. He's a Kotlin product manager. Trade-offs are constant and inevitable. We trade convenience for performance. We trade consistency for compatibility. Trade ease of use for features. I really like this tweet. Kotlin, of course, I mean, I bash Kotlin on Twitter all the time, sometimes, because it's funny to make fun of something popular, but Kotlin does something very right. They're all about trade-offs. Their paradigm is be programmatic. Don't be backwards compatible all the time, but be pragmatic. Find the right way to, it's somewhere in the middle, right? But in terms of naming, I think it's really better to get it first the right time. Just spend a little more time and think about the names and talk to each other. Another example, I'm still glad Mario's sitting here, so I stole this from you. You had this in your previous talks many years ago. Monads in Java, really cool. Now we have Stream API, this is a monad. What is a monad? In short, it's kind of a type that returns itself, but with a different contained type, what you call map and flat map. So you can pass functions to map and flat map. And what you get back is still a stream, but the contained type is no longer R, but it's the mapped type, right? So a monad is much more than that, but the monad API should look something like this. And we have more monads. Optional is also a monad. Really nice. And we have completion stage, which is also a monad. Except, no. Then apply, then compose, right? So in terms of naming, it is not, although it is. So when you look at the JDK 8 Java doc, you didn't see this line here. I think someone was connected with Mario and saw his talk about how he ranted about this, and then they amended the Java doc to remind everyone. So it's still kind of the same thing, but just a different name. Trade-offs. Some examples. So this is really a cool API. You should try once. I really like this API. I really like this one. A lot of good examples in this talk for good API design. And it's actually mean because it was very simple design, right? So every SQL method, every SQL keyword has a method name. So there's absolutely nothing that I can do wrong when I design this API. Yet you think so. Even Juke has its warts, like this here. In the old days, Juke 1.0, I decided to call this thing a field. Because it's a database field, kind of like in Microsoft Excel, a field, column, cell, you could call it whatever you want. It's a field here, historically, and you have functions, you can substring a field, and you get back a field. And then this happened. I don't know why. I can't tell you why this happened. Suddenly I called it a column. What now? Is it a field or a column? Can I fix it? And how much code will I break if I fix it? So this happens to everyone. Naming is really hard. Now, of course, bad naming in their API, it sucks, right? And bad naming my API, it's a feature, right? This is how we deal with these kind of things. And trust me, there are other kinds of things, like this thing, which I call the condition. Because it is a condition in a way. You pass a condition to do a SQL where clause. It's kind of a condition by which you select your rows that you want to get back. But technically, and according to relational algebra, predicate would be nicer. And this is me every day. Since I designed condition, should I rename it to predicate? Right? I really want to rename this because predicate is much more pure in terms of naming. Changing that would be super easy. Just go to the IDE, rename, and I'm done. But then you have to change the docs. And don't just change the docs, please. HTTP 301 is a thing. Redirect the old docs to the new one. So many tools don't do that. And you have tons of dead links all over the internet because you have external docs as well, like Stack Overflow. And this is the most obvious one. So if you have Spring documentation is linked from all over Stack Overflow. Java documentation is linked from all over Stack Overflow. If you change the URLs, that's horrible, right? So you have to think about all of these things. You have to write good release notes so everyone knows, okay, this is a huge breaking change. I have to pay attention to this. Okay, it's better now, but I do have to do the work. You have to maybe even keep the old name around for backwards compatibility. I mean, the new predicate could subtype the condition, and then everything still works, maybe. Question is it still worth it? Better get it right the first time. Like, this is a good example. I really like JSR 3.10. I like the Java Time API. It takes a little bit of time to get used to, I think, in my opinion, because it's all value types. We're not used to that. Value-based types, I mean, everything is final, and it works a bit different from all the other JDK APIs, but if you look at it, it's really, really consistent. Now is a very obvious method name. Every type has a now method, and it's obvious what it means. It's this type now, right? The current local date, the current local time. They could have called it current, fine, but it chose now, and it's now everywhere. There's parse. So by default, parses an ISO string into that type. Into that type, you immediately know what it does. When you read it, you know what it does. Like ranty says what it says and does what it says on the tin. Off, the off method. This is now a convenience. This is what Java APIs now do a lot of times. Off is to construct something of something else, of its parts. List off constructs a list of its elements. And here we have a local date of its parts, year, month, day of month. There are other names, other language in this API. At creates a more precise value from a different value. So from a less precise value, the local date, you can create a more precise one, like local date time, at that instant, or whatever the at argument is. Get extracts part is run the check. Minus and plus are arithmetic. And we can discover this API very easily and learn what it can do just by looking at the names. Nothing more than the names. We can learn it, and it's the same everywhere. This is really well designed. With replaces a part. So with is something that we've come to use in Spring APIs. It's an unofficial Java Beans extension where we can modify an attribute regardless if it's mutable or not, and we get back the type instead of void. There's more language: start of day, day of month, and day of month is something else than day, and we can learn this language. Not just that, not just this language, but object orientation has a couple of guidelines. Like we've always used adjectives for interfaces, except there's some exceptions, of course, but this is kind of a guideline. Nouns for classes, verbs for methods, and we can build this language. This language we can use to send messages. So I really think this is something, I put it at the first bullet, this better get it right from the beginning, because this is one of the most important parts of designing an API. Much more important than local variables, which are not that essential, but API naming is one of the most essential things. Simplicity. There's a quote, which may or may not have been from Mark Twain. We never know these days. I didn't have time to write a short letter, so I wrote a long one instead. I like it, right? So everyone who works in the enterprise knows how this works, so we get emails like this, because the managers don't have time to be concise. They write a long email. And if Mark Twain lived today, he would also say, I didn't have time to think about who this is for, so I CC'd everyone instead. Okay? We can all relate? Excellent. I've also found other quotes, so you just Google simplicity quote, and then you find random quotes on the internet. I found this one nice. It's more spiritual. It is pointless to do with more what can be done with fewer, from William of Ockham. I have no clue who this is, but I found the quote quite interesting in this context, or Mother Teresa. The more you have, the more you are occupied, the less you have, the more free you are. Why the spiritual context? Ultimately, again, this is about humans and about our emotions. I think this kind of simplicity in terms of how you want to lead your life, which we all don't. We have so much, I don't know, we live in a capitalist world, we have so much possession, but we actually strive for that. We strive for getting rid of all that craft, like we strive for getting rid of these parameters. Have you ever worked with this API? I've compiled a couple of things in runtime, and there's a JDK API Java compiler. It extends tools and option checker, and you can get a task. And I'm not sure yet if this is synchronous or not, but there's a task which you can invoke something on afterwards, but you have to pass it a writer called out. And I don't know what that is. I mean, is it the error stream, or what do I get here? Do I get classes? And I have to pass it a file manager and a listener. And this just causes existential angst in me. I don't know what we do, but when I have something like this, I just, how do I use this? And it's important. I'm compiling stuff. I want to get it right. So I have 6 parameters. They're stringly typed. I have an iterable of list of options. What is this? I don't even use iterable. I mean, of course, it's the top level type for collections, but I understand the rationale. But what I'm passing here on this Java file object is quite. You have to read tutorials about how to create a Java file object and how is it different from the Java file manager. None of these things are inherently bad. The implementation works very well. If you've ever compiled something at runtime, it just works. It's wonderful. It's a wonderful implementation. But I think the API is not designed for humans, not for me at least. It's designed for maybe building tools on top of it. We can only keep so many things in our heads at a time. Complicated APIs are frustrating. This would be an alternative. I've written this library. It's just a small reflection and compilation utility that just built on top of existing utilities. Google has one as well. Where just all I care about when I compile something at runtime is the class name and the content as a string, most of the times. Of course, you need a lower level API that can do much, much more, but there should be convenience. I'll get to the point of convenience afterwards. I watched this talk by Josh Bloch. A really good talk. I recommend you watch it. An opinionated history of APIs. And he has a lot of good talks about APIs. He's designed APIs all of his life. And he dug out a paper by DJ Wheeler from 1952. The prime objectives to be borne in mind when constructing subroutine libraries, which is kind of like an API, are simplicity of use, correctness of codes, and accuracy of description. Here we are. Names and simplicity, right? Complexity should, if possible, be buried out of sight. Wheeler was one of the first people to ever design APIs. So this was news. Everything he did, he invented, kind of, or he kind of discovered. And he also invented bike shedding, right? So he couldn't resist in his 2-page paper to discuss whether routines should be stored on punched paper tape or on auxiliary store, right? So we can never resist in getting down to lower level details instead of looking at the big picture. So he invented both of them. It's kind of the tabs versus spaces of the 50s. But being simple is the important thing here. It's really difficult to be simple. Some things seem obvious, right? We have heard low coupling, cohesion, and these kind of terms, solid, Liskov principle, etc. There are a lot of principles and guidelines, but it's very hard to be simple. It's a lot of work. It emerges from very careful design and reiterations. You have to iterate to be simple. I don't think any API is simple from scratch. JSR 3.10 has a long history as Yoda time, and it got better and better before it had to be set in stone and never be breaking backwards compatible. So this has a long history, so it's easier to be simple if you actually have this time. I think simplicity is like obscenity. I've seen this quote here. I'm not going to say in which context it was said, but I know it when I see it, right? We know and recognize simplicity, but it's really hard to do it. One way to do it is bullet number 3, do. I don't know who comes up with these acronyms, but this one means do one thing and do it well. It originates from the Unix communities. So Eric Raymond's 17 Unix rules. Don't read all of them, but many of them are about simplicity and doing one thing. If you look at this, build modular programs, use composition, write simple programs, small programs, transparent programs, etc. So these 17 Unix rules are really great because Unix is a great operating system for these kind of things. Maybe not for the enterprise, but for programmers. It's really great because you can compose these little programs into bigger ones. And you can't be simple without doing one thing. This is just a separate bullet, although it's kind of similar. I wanted to have it separate. But the most important bullet probably is types. Type safety is one of those bike sheds. So the bike shed comes back again all the time. I think great APIs can exist without type safety, but I don't think they can exist without types. Now I think jQuery is a great API, and there are types in the docs everywhere. You see them. JavaScript doesn't really have type safety, but it has types. I have a function here. It takes an integer, an element argument, and returns a Boolean. So it's in the docs, and it's in the runtime. It's just not in the type checker. When you code it, you don't see it. It doesn't help you. But there is a type, and you can attach documentation to it. You can communicate to the user through it. A type is important, regardless if you check it. Likewise, there isn't really a schema-less database. There is always a schema. The question is, do you read is it a schema on read or a schema on write database? Do you enforce the schema when you write, or do you allow any type of data to be written and then discover the schema when you read it? But in your head, in your design, there is a schema always. You always design a schema, except for some very weird exceptions maybe. But you have that, and you have a couple of very decisive advantages when you have types, like these 10. You can have a name, you can simplify your design, you can do one thing, you have type safety as an option. They help you discover the API, discover. This is actually the same list as the outline of this talk. Types, or this talk is about types. Types are super important, and spending time to design types is super important. Now, I don't care if it's object-oriented or functional. There are different ways to design types. Ultimately, just spend the time to think about them. Now, there's two kinds of typing. There's usually nominal typing. So there are two groups of people. Also not a really good dichotomy, but some people like nominal typing. Spring people historically liked nominal typing, so this is a very nice nominal typed name. It does one thing, I think, and it implements another thing. So this is one approach to typing. You can also have structural types. I like structural types. It's more functional sometimes, so Spring has released this blog post with a nice structural type. Right? So you're all thinking what I'm thinking here? We need to go deeper, exactly. We need more types in the structural type. I think this would be a better example for the initial tutorial for this HTOS, or however you pronounce it. And make no mistake, this is not a merge conflict here. This is part of the Java syntax. So some people add syntax sugar, others add syntax vinegar. Yeah, it's so easy to make fun of others. It's always easy to make fun of others. Here's a nice Juke type. I will introspect today. I'm going to be fair. Nice Juke type, Juke API type. And you see this is a method, one method, it returns one type. The type name is here, right, in the middle. And actually I had this happen to me recently. This was a fun tweet. If you zoom into this, you see the compilation error. You don't get that when you use Juke, but when you develop Juke, you have these kind of compilation errors. So what's the point here? If you have this kind of row type with 22 columns, you can attach methods to it that also accept the same type variables, blah, blah, and you just think, well, still, yeah, how does it help me? You can, with structural types, have a row of 3 columns and then try to make it equal to any of this subselect here, and whenever you make a mistake in the subselect, you get a compilation error because that doesn't type check anymore. So types, the point of the types here is types are semantic. Regardless if they're infrastructure types or business types, they're semantic. They convey meaning, whatever the meaning is. They self-document. And again, it's not about type safety, it's just about the type. It works with nominal and structural typing. It works with static and dynamic typing. The most important thing is that you think about it. I made fun of this example from Spring. I made fun of this. The important thing that you always have to remember is this type here. This is yours, right? This is the interesting type, the only one. The other ones are infrastructure types. And sometimes what we do get wrong in APIs and also in implementation is we mix them too much. Infrastructure types are important from infrastructure logic, but we shouldn't let them leak into the business logic, right? So this is, of course, an API endpoint for REST. So this is OK because it's the endpoint, and you have to wrap your type into an infrastructure type. But sometimes we do the same thing in our own logic. There are counterexamples. What happens if you don't have types? Like here. We know this API. We've loved it. Connection, create a statement in JDBC, and then we can pass it some result set types, or concurrency. And these are ints, right? So the good old days was define constant as ints, like in C. Now these things are neither documented in connection nor in statement. If I want to pass one of these int constants, I have to search a result set, which is not really involved in this API interaction here, right? It's called result set type, but I'm creating a statement. So this is really difficult to discover because there's no type. Int is just a value, it's not a type. If we had enums back then, obviously they would have designed it like this. But it's too late now. Another example from the old days, and you probably have similar examples, is this. I just looked up random examples from the JDK, and we have Sax parser properties, and these are URLs. These properties are usually URLs with an object value. And this means I can just pass anything to the implementation. If I read the documentation, I'm fine, but the point is, this is stringly typed. I don't know immediately what I have to pass here. This is very difficult for an API user. Of course, it works, but for the human that uses it without types, it's difficult to use the API. So sometimes it's inevitable, but if you can, use types for everything. And of course, I can't have a talk without discussing annotations. You know what else is stringly types? Annotations, yes? So some APIs have started investing a lot in annotations. I think that was the wrong way because it doesn't convey enough meaning. An annotation can be useful because you can add processing instructions and attach that to methods or whatever object, but for metaprogramming it's great, but it's all stringly typed. We can't, for instance, pass a lambda to some annotation. That would be really great. Bullet number 5, discoverability. So now you've already guessed, I couldn't discover the results at type. This is a really important concept. Discoverability, I think, is very important. So let's go to discover on Stack Overflow. How do you find a good or bad API? And obviously, because that's such a great question, it's closed. And I like this answer. It was not the accepted or the top answer, but I like this one. You don't have to read the documentation to use it correctly. The sign of an awesome API. I try to live by that. Now, documentation is important, but do you have to read the documentation? No. It would be great if I could just go and type stuff and use an IDE for your choice and stream off 1, 2, 3. And the stream API works really nicely. Incidentally, because it's fluent, but that's not the main reason. It could be different. It could be working different. I could just discover my options. I don't even have to think about all the types all the time. I can discover things and only look at the types when I need to. There's another obviously great API. This one. All right, so I have to show you the example. If you know SQL, if you know your way around SQL, you want to write select, you just start typing and you have all the statements as in the options here, and you select the film, you know your tables and your column names. Auto-completion is something everyone uses. We all use IDEs. An API should leverage the fact that we have IDEs. It's very easy for APIs to design for IDE usage. Of course, it should work without IDEs as well, but discovering an API helps the user be much, much faster when they learn it and much more efficient when they already know it. Remember usability. This is a very important part of usability. Now, some people like reading docs, others like navigating API. I think your API should accommodate both. An API should have a very small set of entry points. I recently heard this again from someone else, from Christian Humer. Is he here? By coincidence, also, I think he lives in Zurich, working for Oracle Labs. An embedded DSL should have domain-specific errors. So this was about the other tweet with the huge exception from the compiler, but only have a single entry point to the API. So this is really something that helps a user discover the API, the single entry point. Actually, JPA has done this quite nicely. If you have the entity manager, once you have it, you can discover your options from the entity manager and create a native query, and there are overloads, so you know immediately what it does. You create a native query, and you want to get an entity back, and you get a result list. And then you can iterate the result list and call the size method on the actors, and then boom, right? N+1. But anyway, you can discover this stuff very easily. But now I'm interested in this. I've written a unit test that just has an entity manager somewhere. What I wanted is, I had a data source. I wanted to get an entity manager from it. I thought that was the same thing. But what I got is this. I used Spring. I used some tutorials. I read some tutorials. And I just had a data source, and I thought an entity manager is just a cache around the data source and some things in addition to the cache, but I had to configure so many things. Like this one here, I picked this at random. I don't know what it is. It's too complicated. I searched the Spring API for Entity Manager, and I found this one, and it was actually one of 3 options, or 2 options. The one was abstract, and the other ones, I chose one. What's the difference between? Of course, I can read the documentation, but I couldn't discover it. I had to say Hibernate 3 times for this test. I had to tell this API 3 times, yeah, I'm really using Hibernate. And then I don't know what this is. I don't even know. Maybe it wasn't necessary, but I found it in a tutorial, and they called after property set. If I didn't do it, maybe just everything broke apart, and then I have get object. So me as a user, I had no idea what I'm doing. Maybe I was using it completely wrong. Maybe there was a much, much better API in Spring to do this kind of thing. Or maybe even in Hibernate, but I couldn't discover it. It took me way too long. I have no confidence that I did it right. I hope Ollie from Spring will not be mad at me for quoting this. This is how I often feel with Spring. It doesn't click with me. If you have implicit programming models, it just doesn't click with me. He said knowing what you're doing is important. Of course, he's a Spring maintainer. Of course, he knows what he does. Like, I know what I do when I do SQL. I just found this interesting, right? He actually told me to read the manual and learn it. And I don't know what I'm doing. I'm not using Spring very often. I'm hardly ever using Spring. I just use Spring for writing examples with Juke, right? And I don't feel bad about not knowing what I'm doing. I think I should just be able to discover it. Docs are great. I think discoverability is better. I'm that kind of guy. There are the others, so you have to accommodate both. That's the important part. both ways are good. Just do both of them. Good examples are Java Stream API, JPA, once you have a Juke, obviously. jQuery, I like that one. Java Time, it's not one entry point, but you have tons of value types, and they're immediately clear, so that's a different way of approaching discoverability. You just go to the package and see what's there, and that works. I liked Whistle. I didn't like SOAP that much, but Whistle was nice. It's a standard way of designing XSD, and you can just communicate to your to whoever calls your API. This is the API, and you can read the whole file and see what's there, and all that's there is there. Maybe it explodes if you have a huge API, but I think the approach was good. Swagger can do the same thing. Yeah, let's just one more moment. I have to do it. I appreciate how good an example Juke is. Okay. Error handling. Error handling. Bullet number 6. I have to speed up. So this is why I just skipped this, right? This is how we do error handling in Java. Bullet number 7. Consistency. I'm just joking. Error handling. I sometimes work with PL SQL. I like the language. I sometimes forget the exact syntax, and then PL SQL will tell me what the exact syntax is. I'm sitting there. Okay, I wrote end, and end is forbidden. I have these options. I just wanted to send an empty block somewhere. I don't know. How about this error message? Block cannot be empty. At least one statement must be provided. I would be, oh, yeah, I remember now. This is PL SQL. I can have an empty block syntactically. I put this null statement here. I'm done. Error handling is also part of these 17 Unix rules. So in the middle, you find error handling. Writes transparent programs, robust programs, easy to diagnose. This is very important. Not the error handling itself, just in terms of stability, but in terms of communicating to the user what it is. We can bike shed about how to do it. Yes, in C we did it like this, and you can just ignore the error code and who cares, right? We can ignore everything in C, and in Java we can ignore the exceptions, just ignore them, right? And maybe system exit to teach them, right? And if you're a functional programming, you're one of the cool kids who knows Scala, you're going to return either and flat map your errors and etc. We can still ignore the errors, so we feel smart about ignoring the errors. But this kind of discussion is mostly irrelevant, I think. In terms of API design, of course, there are pros and cons, but the most important thing is you be consistent and return meaningful errors, and the caller should always know what to do and when they can ignore it and when not. I think we still haven't figured this out. Types are probably better than strings and ints, but if it's an exception, which is actually a fancy way of writing a union type with some control flow meddled into it, and then you don't have to unnest the union type again, check the exceptions, you have to unnest it, but if you don't, you can just rethrow. It's kind of weird. Exceptions are weird, but the try monad and the either monad are also kind of weird. You have these structural types that just nest forever. I don't think there's a true or wrong answer here, but you have to be consistent and choose one thing and communicate, right? So we can maybe in 10 years reiterate the technology. Consistency. Random quote again. So Bruce Springsteen is consistent in his work. Why? Because with consistency, you can improve the efficiency and memorability, I think. When you're consistent, everything's always the same. People don't have problems being efficient with your API. Now here's an average enterprise bean, right? Is it consistent? My bad, this is not the right one. So this is the average enterprise bean, right? We have these annotations here. Average enterprise bean, right? Yeah, if you've seen my talks, you know my jokes are always the same. Okay, so this feels kind of weird. If you look at it closely, I was too fast, but we're running out of time. If you look at it closely, it grew over time, and we sometimes return a list, sometimes a stream, sometimes an array. They're all the same thing. Conceptually, they're different types, structural types, infrastructure types, but they're the same thing. 0 to n arity. And here we have 0 to 1 arity. Sometimes we return optional, sometimes a nullable object, and in the old days, we threw an exception, object not found. It's possible if all your API throws an exception, well, it kind of sucks, but it's consistent. It's easy to learn, right? So all choices are fine, in my opinion. Don't bike shit too much, but pick only one, right? So consistency. I'm going to skip this part about Liskov substitution principle, which is a principle we all know and should adhere to, and you can see in the JDK, it's not. So depending on which set you're using, you get different results. It's kind of weird. JDK collection API is a real foot gun. We should get rid of it and build it afresh, but it's too late for that. Yeah, I have to skip through these parts because we're running late. Another API that is not always very consistent. If you work with this language, Anyone worked with this language? So if it's an array, you search the needle in the haystack. If it's a string, you search in the haystack the needle. And who can ever remember that? This language here is not statically typed, so you both compile. Everything always compiles. And if you're not absolutely fluent, you have to look this up in the doc all the time. This is PHP. And they have this all over the place. So for instance, if you filter an array using a callback, or you can use a callback to map an array, right? And we have this example, which you all know. You can watch it talk. JavaScript is similar. Consistency is just, we don't know how it works. Why consistency? JSR 3.10 was a good example, because once we've learned the language, once we've learned the API, we know exactly how to use it, and we have no surprises. It's at the core of usability. All of these things are affected by consistency. Usability is really, consistency and usability, very closely related. Convenience is the 8th bullet. Here's a quote by Brian Getz. I like his quotes, very often his good tweets. Key API design questions to ask yourself. What abstractions am I asking the users to understand before they can use the API? Do those abstractions serve the user or just the API? Yeah? His example was JMS API. You have to instantiate so many objects until you can send a message. This is solved with convenience because all of these things are necessary. Lower level types. But just to send one message, I sometimes would just like to have a static method or maybe an instance method of one type. We had this forever, right? Input stream, output stream. And if you're not allowed to use an external dependency, you write this all this single time, yeah. You have to copy paste it from Google, and it takes so much time. And 9 major releases later, we finally have convenience on the input stream. We can now transfer the input stream to the output stream. This feels great. Convenience, in my opinion, is the most underrated API feature and language feature as well. How to achieve convenience? In my opinion, one way is by dogfooding. Dogfooding is an approach to achieve convenience. Why? Because you're using your API all the time. Dogfooding is a term from English which I don't fully understand. It's kind of weird, but you're eating your own dog food that you produce. So you're actually tasting what you're producing. So when I use my own API, I feel like this, right? I see, oh, this sucks, I have to do it better. To be fair, I feel like this with any API. When I use any API, right? Frustrated. But at least I can fix my own. The advantages of dogfooding are I have better objective quality. So this is one example. When I do Juke, I'm pretty sure this works because I have this kind of SQL query inside of the library. So I'm sure it works, but dogfooding is also for better subjective quality. Suddenly I had a revelation. I should change some types in the API. Why? Because I wrote this 1,000 times in the integration test. Every time I called fetch, and it got on my nerves. And then I thought, can't I just do it like this? What is this type? It's a result query, and couldn't it just extend iterable, and then I'm done. Calling iterator on it will execute a query, just like fetch, but more convenient, just like in PL SQL. So this is something you should think about often, because convenience, I skipped this part, convenience is not a game changer. It doesn't solve the big problems, the business problems, but it makes people happy. Remember the last bullet in the usability slide, convenience is very, very important. Happy people will recommend your API and love working with it. And we have convenience in the language as well. So no one wants to go back to pre-Java 7 days and do these kind of things in the language. Compatibility, you can only lose. So this is one of the hardest topic. Don't do it like this. Don't do it like Python. Right? Just don't do that. Don't do that. Syntax error. So yeah, it's a special function without parameters. It's just print. Just leave it like there. Everyone uses Python for scripts, and all the scripts will be broken because in scripts you print a lot. You don't gain a lot from little changes. On the other hand, in Java, we have this method on Boolean. Boolean get Boolean string. What does it do? System property. Wow. It's really weird. You wouldn't use it like that, probably. And we should remove it because it's not consistent, but it's not being removed in the JDK. JDK is very slow to remove things. So I think we should have more Mary Kondo in the JDK. Be pragmatic about compatibility. There are good books about that. Keep the old API tests around. It's a good approach to be compatible because the old tests will have to run with the new version of the API. Eclipse is very compatible. They're internal APIs. They even have compatible URLs. They use always as a suffix 2, 3, 4. That's how it works. Read that stuff. It's hard to get right. The final bullet is documentation. How developers feel about documentation. How does it work, documentation? Yeah. It's just like unit testing. We had this discussion yesterday, Gerald. Just like unit testing. Where are tests? They're at the end. We can postpone them in the project, right? Documentation, we have this code, and then the architect tells you to document it. So you go and document it, right? But documentation is the dual of discoverability. Don't underestimate it in an API. Discoverability is, I don't know what I need. API, what do you have to offer? Documentation is, I need this thing. API, do you happen to support it? That's one way of using documentation. So it's a dual. You have to do both. I can't tell you how to do it. There are good tutorials. I like this one from Devio, a company from Zurich. 4 types of documentations, tutorials and how-to guides are for new users, and explanation and reference are for seasoned users. They're for different purposes. You should have different types of documentation. Read these things. Just don't forget them. We've reached the end of the talk. 10 reasons why we love some APIs and hate some other. Thank you. As I said, we've reached the end of the talk. Naming, simplicity, etc. Or in short, NSDAC. Remember, NSDAC, quote this, G is silent. Designed for humans. If you don't think programmers are humans, I have some proof here for you. Programmers are humans too. Try that and you will see the human emotion in the programmer. Check out Geek and Poke comics, I really love them. We've learned about usability. API design is about usability. I like this definition. Learnability, efficiency, memorability, errors, satisfaction. Before we finish, some more consumer information. I just can't keep it. Let's once more talk about Juke. Do check it out, because all of what I said is in Juke, including the mistakes and learnings. And I will write a transcript of this blog post, of this talk, and go more into details. Maybe next year I will do a more detailed talk if someone is interested about how this is done in Juke, what rules are implemented in Juke. This is how you feel when you work with Juke. So consumer information, great. You're all done, hungry. Thank you very much for your attention, and have an excellent remaining Vox days.